Today, I'm circling back around to market conditions and how to apply time adjustment and to do time series analysis. And I have been pretty critical of regression to solve this particular problem. And I want to give an example of how regression makes something more complicated that doesn't need to be. So what you're looking at right now is a chart that I created from the Dow Jones. I downloaded a data set and decided to take a look at a few things. So when we're looking at the Dow, if we're applying a linear regression line, this is the last year, and what I've done is I've indexed it to 100. 100 being today. Well, actually yesterday. This is the pricing as of yesterday, and I wanted to do that for a reason. I'm going to show you how indexing is really helpful for comparing different price levels at moments in time. Here nor there for right this second. Where we're going to start is I've got a linear regression line. And what you can see is that the linear regression line doesn't do a good job of describing what has happened to prices of the Dow Jones over the last year. We've had a lot of price changes, and while the year-long linear regression line is generally showing that yes, the Dow has gone up at a certain average rate over the last year. To put it in easier to understand terms, that is not really very helpful when we're doing what we're trying to accomplish in a time series analysis. And what we're trying to do is to put ourselves at a moment in time, which is not at the middle of this data set. We're generally trying to put ourselves at the moment in time at the very end of this data set. And when we're comparing time, this regression line has it has a slope to it. And if we're looking backward from this regression line at that slope, it's going to have us applying wrong way adjustments. You can see if we're looking to normalize the pricing of the Dow Jones in this case, instead of real estate, we're just looking at an industrial average of stock pricing, and that would go a completely different direction. You can see when we scroll down, I segmented the chart into smaller segments. So here is a 6-month segment of the Dow Jones. So it's the same chart, just in 6 months, and you see that the line changes dramatically. And what if we look at 3 months? Again, the line changes very dramatically in this last chart. So what we want to notice here is that that the time span that you're studying is super important when you're doing regression. It's going to change your results dramatically. We can switch all of these to a different form of regression. So let's do that. I'm going to take just a second, and I'm going to switch them all to a different kind, and then I will talk about that. Okay, I have changed all of these graphs to a polynomial 2, so a second degree polynomial function, and that is going to change things a little bit. You can see it's actually matches a little bit better on this year chart. But when you look at each segment in time, there's a whole year, there's applying it to 6 months, there's applying it to 3 months. It changes the shape of that line dramatically. And keep in mind, the slope of the line, or the shape of the line, the curvature of the line is going to have massive effects on your adjustment rates if you're trying to create a line and use that line to create adjustment rates for different moments in time. And so this is why I am not a proponent of regression for this problem. I'll show you real quick. Part of the reason for this is regression lines have properties. So a second degree polynomial has properties to it. It will, no matter what your data looks like, it's going to create an upward or a downward parabola. That is just the properties of that line. Same thing with other types. So you can add terms to make a cubic function, and that would be a third degree polynomial, and they create a particular type of curve. It creates a type of an S-curve. And that's just the way that those functions are designed. And so we really want to be careful when we're applying regression, because you just need to know that your market isn't going to fit into a particular formulaic pattern. That's not what we're looking for here. Polynomial regression is really great for certain tasks, and it tends to be things where you're predicting something that you already know behaves in that way. So you're applying that particular line for a reason. And this problem is not the same type of problem. The reason I converted the Dow Jones to an index here is just to show you how easy working with an index is. If I take this, I'm going to zoom in a little bit. If I take this most recent moment in time, let's call that the effective date, and that's indexed at 100. Well, if I'm looking back at what the pricing was in the market for Dow Jones stocks, a couple of months ago, it's around 106. That means it's 6% higher. Very easy to work with an index like that. So if this were the effective date and this was dealing with real estate price indexes that are for my market, then this would tell me that I needed to adjust down 6%. It's very simple, and it solves the problem in that particular way. Now, the question is, how do we create an index for our market? And that's something that I have created a workbook and a technique to do that. And this is by far the best way to solve the problem of market change.